Hello, I'm Nimesh, and today I'm going to be presenting our course project on the topic sustainable housing colonies. My teammates are Sudharam and Sumit. So, introduction. There are many different reactors for different sizes, and so it's important for us to know which one of them is best for environment as well as economically feasible. So, our motivation comes from basically to save resources and clean and reuse water and make it safe for household waste. And the objectives for our research are to build an efficient water treatment plant for a housing facility. And for that, we are using a LCA to examine the sustainability and environmental effects of the reactors. And we are also evaluating the economic feasibility of a water treatment plant using techno-economic assessment. So this is the modeling approach. We are assuming a water facility for a community of 2,000 individuals, which are residing in 500 houses, and each accommodating 4 residents. Assuming 5 liters of water is required for every individual, so total 10,000 liters per day water is required for entire community. And for that, we are using LCA and techno-economic assessment. And the ultimate goal is to uh, to determine which capacity of water treatment plant is best for the environment and economic viability. Yeah. So this is the model outline. First, we mix groundwater and sewage water with recycled wastewater from in the mixer, and then in the electrocoagulation reactor, the wastewater goes electrocoagulation. We use borosilicate glass container with aluminum cathode and anode, and we apply electricity. And this process removes harmful metals from the wastewater. And in the sedimentation tank, we put the water for 4 hours, and almost 80% of the water is treated, and remaining 20% of wastewater is sent to the sludge separator. In the sludge separator, it is basically a centrifuge or filter press. The outlet of sludge separator contains 2% of the input, which is the wet sludge, and 98% of the input, which is the recycled wastewater, which is mixed into the mixer. Yeah, and the last process is drying, in which the wet sludge is dried in this process, and almost 99% of the water is evaporated from the wet sludge, and 1% of that is a dry sludge. Yeah. So this is an explanation which I explained earlier. So thank you.
Hi, this is Sumit. I'm going to explain the calculation involved in our modeling. So here we are considering 4 reactors of different capacities of 1,000 liter, 550 liter, 100 liter, and 20 liters respectively. And then the capacity we are expecting is 10,000 liters of clean water per day. And the residence time here is 95 minutes. So I have calculated the flow rates by using this formula. And then the number of reactors is calculated by dividing the required capacity with the flow rates of the different reactors. And then the electricity requirement here is calculated. Now, the flow rates and number of reactors and electricity requirements are already calculated. Now, the dry sludge flow rate and wet sludge flow rate and the treated water from sedimentation tank and filter press input is calculated here. And we have used these formulas from the research paper itself. And we have like flow rates we have already calculated, and the sedimentation, the 0.8 times the flow rate is the sedimentation tank treated water. All these formulas are used. Now we have calculated the cost of different reactors involved in the entire process, like electrocoagulation reactor, sedimentation tank, sludge separator, and dryer and mixer. And these costs are calculated. I have already mentioned the values here in comments, and these are calculated for all the 4 kinds of reactors of different capacities. And also the area calculation, the land area on which the things will be set up, we have calculated it. We have taken the height of the reactor as average height is 5 meters, and the area of base is shown here. And the total land area for all the 4 kinds of reactors are calculated here. And then talking about cost, here we have taken the average land cost as 21,528 rupees per meter square according to Indian standards. And I have calculated the land cost here. And then piping costs are important. Piping cost, I have taken fixed cost as 1 lakh rupees, which involves carrying of wastewater from like a sewage plant or a river to a treatment plant. And then variable cost is we have taken it as a function of length of the pipe and multiple other factors like diameter and thickness of the pipe. And it is calculated here. And reviewing this, the most visible is 550 liter reactor. Thank you.
Hello, I'm Sundram. Let us see what is life cycle assessment. LCA is mainly used to compare 2 processes, like which one is better for our environment. Assumption for LCA, we have taken residence time 95 minutes and electricity consumed in the sludge separator for different reactor as 1 HP, and you can see the what I've taken electricity, and electricity consumed in dryer would be equal to 3.6 kW for 1 kg of wet sludge. And we have attached this image from Gavi software, and let's see what is the reactor volume versus CO2 emission, GWP 100 years per reactor, and CO2 versus reactor volume, in which you can see that 1,000 liter reactor volume reactor is very good for environment for only for 1 reactor. But if you will see for whole reactor, then here 550 liter reactor will be better for our plant. Let us see what is techno-economic assessment. Techno-economic assessment is a method to analyzing the economic performance of an industrial process and product or services. Assumption used for our model is mainly like cost of electrocoagulation reactor will be equal to cost of aluminum sheet plus cost of borosilicate glass container plus cost of electricity. And for this numerical cost we have calculated from the many e-commerce website, and we have taken average from those websites. And for area calculation, we have taken the same height equal to 5 meter and have calculated surface area from this height, and same thing. And here the main point, we are assuming a fixed cost of 1 lakh rupee to receive wastewater from sewage or groundwater. The result from TA we got, like we can see that the cost of 550 liter volume is most optimized and economically feasible option for the setting of the plant. And the conclusion we got, 550 liter reactor is best is the optimal choice for establishing a water treatment plant in housing colony and balancing economic feasibility and sustainability. The best suitable order for setting up a water treatment plant is considering environmental impact and economic feasibility is mainly 550 is best and 21 is less suitable for our project. These are the references, and thank you.